In today's lecture, we're going to solve some math from the chapter 6 in the data communication courses. Chapter 6 is all about the multiplexing and spreading. In the very first example, we'll be talking about the frequency hopping spread spectrum. If you're given a graph or a k-bit pattern, sorry, not a graph, you have to draw the graph. If you're given a k-bit pattern and some frequency table, how can you draw the FHSS cycle or frequency hopping spectrum cycles graph? Basically, the question is all about that if you are given this type of the table for the frequency generator, frequency hopping FHSS generator, how you can draw those things using how you can draw this type of graph using the frequency table and the k-bit patterns table. And as we already know that if you have a k-bit pattern, all the patterns give you some kind of random numbers in a random order. You have to then you have some kind of frequency table. In that table, all of your random numbers, your k-bit random numbers corresponds to some frequency. And if you get some random number, let's say here we have got 101, and our first selection, so this is our pattern number 1, or for first selection, whatever I might prefer to call it. The first selection is going for the 700 kilohertz. And then again, the second one, and the second pattern, 111 would go for the 900 kilohertz. And the third pattern, 001, it is going to be on the 300 kilohertz. So, but basically, we're going to take the random numbers within the random range, within the ranges, and then we're trying to match that. What is my random number corresponds to the frequency? Basically, it's trying to understanding like if your ID number is that, if a student ID is that, to whom we will be calling to come on the guys and give some kind of lectures, okay, to show their presentation or something. So basically the idea behind this is, this idea behind this is pretty much easier. You will be taking one selection or one pattern at a time. You will try to match the corresponding frequency hopping table, and then you will try to plot those things on the x-axis and y-axis. Okay, basically it's basically a scatter plot or the xy plot. Now let us show this graph, how you can do it. So first of all, you will have a k-bit pattern, and the thing is that we already know that the k-bit pattern is basically a binary bit pattern, so there will be only 1, 0, or 0 or 1s. And can you discover, or can you find what is my value of the k? So we know that the value of the k should be a number to which power 2 to the power k should be the number of the selection or number of the frequency. You can spread spectrum. You can do the spectrum using this table. So how many numbers do we have? We have the numbers of 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 numbers total here. So we have 8 numbers or 8 patterns. Okay, not the numbers. Let's say that we have 8 patterns. So log twice base 8, that is going to be my k. So this is basically the 3. So you have a 3-bit pattern or k8 patterns. Basically, those meaning are the same. If we had 4 patterns, then your k will be 2. If we have 16 patterns, then your k will be 4. Basically, the idea behind this is very much simple. With using a 3-bit, you can make 8 patterns, or you can make 8 numbers. Each of them will be of 3 length 3. So enough rambling. Let us get started directly to our question. The question says that draw the FHSS cycle 3 times using the above pseudocode random generator k-bit pattern and given the frequency table. So basically what you're going to do now, we're going to make some grid, make some XY grid. If in the exam script, if they give the graph paper, you can use the graph paper. Even they don't give the graph paper, is basically draw something like this. Okay, you're going to draw an XY axis where your x-axis will contain the hop periods or the number of the patterns you're going to find, and then you have the carrier frequency on the y-axis, which is basically your frequencies. So we have to remember on one thing here in the x-axis, the hop periods means which of the hop periods is basically meaning the selection. Okay, the hop periods are basically the selection. So in the first selection, it is 101. So this is my first hop. In the second selection, the pattern is 111. So I will be going for the 111 or the second hop period. The third hop period or third pattern is the 001, or the third selection is the 001. Basically, these are my ideas over here. Okay, so so let us now do this math directly. In the very first case, we have an 101. So 101 is matching with the 700 kilohertz. So for the first selection, we'll be going for the 700 kilohertz. So this will be my box. I'll be choosing this box. This is my 700 ranges, 700 kilohertz range. So basically, just draw this graph. This is your first bit pattern, first half signal, first cycle graph, what people might prefer to call it. So basically, we're drawing, this is our FHSS cycle graph. Okay. And the first pattern is gone. Now the second pattern says us to go for the 111. So if you go for the 111, this is my 900 kilohertz. So for the second one, I think I have to move a little bit over here because this was not my first one. My first one should be on the 700 kilohertz. This is my first one line. So this will be my 700 kilohertz. I'm just moving in one grid from the left to right because that was my zeros position. Now this is my ones position. Okay. So my second base signal, the second selection is saying me to take this thing on the triple one. So 900 parts. So 900. So basically this is my 900. Then 900 is gone. Then third selection should be 001. For the 001, we are going for the 300 kilohertz. For the third selection, we're going for the 300 kilohertz. So third selection is here, and my 300 blitz is over. And like this way, you're going to repeat the same steps again and again. So the fourth selection is going to be double 000. The 000 is going to be 200. For the fourth selection, we're going for the 200. So this is my fourth selection, x-axis, and the y-axis, this is my grid for the 200. So the fourth selection is gone. That goes fifth selection. This is 010. So 010 is basically 400 kilohertz. For the fifth selection, I'm going for the 400 kilohertz. This should be here. And for the sixth selection, 110. So this is 800 kilohertz. So this is going to be my 800 kilohertz. Okay. Fill this up a little bit more. So sixth is gone. On the seventh, we have 011. So this is going to be 500 kilohertz. For the seventh, this is going to be my 500 kilohertz. Just going to fill the space. Okay. And the last one, or the eighth selection, this is going to be my 100. So 100 is on the 600. For the eighth part, this is going to be a 600. Yeah, so 600. So we have drawn all those signals we have plotted all those signals in the frequency FHSS cycle graph. So basically our graph will be looking like this, and if we match the graph with our Hooke's graph, you can see we have done the same thing. So if I just cut it out for simplicity, let me cut it out for you. Go to snippet. So as you can see, we have drawn the same type of the graph. As you can see, we have drawn the same graph as the book says, and our graph is literally the same. This is one thing is here that they have asked us to draw the graph 3 times. So this is my very fast graph. This is my time 1. So I've drawn the graph 1 times. Now I have to draw the same graph 2 times. And by the frequency hopping FHSS concept, the thing is that although they seem randoms, they are not randoms because they have a particular pattern. And this k-bit pattern, this 101, then 111, then 001, then 0000010, these patterns are going to be followed in the successive terms, in the next terms. Okay. So in the second case, this is my first frequency cycle number 1. And for the second cycle, I'm going to draw the same thing over and over again. So basically those things, basically this whole graph will be copied again. And as you can see from this book's example, the same graph from 1 to 8, they have been repeated the same graph because that's how the frequency hopping spectrum works actually. Although they seem random, but the same type of the same pattern, the same cycle is repeated again and again. And as a confirmation from the book, I think there will have this clarification over there.